So here we do the second problem that we've been working with the substitution and the graphing. We're going to try it with the elimination method. So the first thing we told you to do is make sure like terms are stacked up on top of each other. So notice how the y's are stacked up, the x's, the equal sign, and then the constants. I know you're looking at this and you say, wait, you had x's here. It doesn't matter what order they're in. So it doesn't matter if x is first or y is first, as long as they're stacked up. All the variables are on one side, the other side is constant, then you're guaranteed to have it lined up correctly. So see how the y's line up? The x's line up here, equals, and then the numbers. So just like we did with the last one, we're going to see if anything can eliminate. So when we work with this problem going down, I have a y and 3y. Remember, if you don't see a coefficient, there's an understood 1. So 1 plus 3 is 4y. Remember, two positives you add. Negative and a negative, you still add. Negative 2, negative 6, we get negative 8x. And over here, negative 2 plus 12, different signs, we're going to get a 10. Notice nothing eliminates. We still have the y's, we still have the x's. Not one variable disappears. So we got a problem. Because one variable doesn't disappear, we have to transform. Transform just means I'm going to take these two equations and rewrite them out so that something will eliminate. So this is where it gets tricky. We said that we didn't have anything that eliminates. So if no term eliminates, go back to the separate equations. Notice I erased the combined stuff of 4y, negative 8x, and 10. I erased that. I went back to the original. And what I'm going to do is I'm going to use parentheses to separate the equations. So notice I'll put parentheses around this equation and parentheses around this equation. You'll see the reason why I have those parentheses in a minute. Next part. Take the coefficient of x, or it could be y. It's whatever you feel more comfortable with. I usually grab whatever is in front here. Okay? So you can decide if you rather do x's or y's. Because the y's are in front in this one, I'm going to grab the coefficient of 1 and 3. So I told you, it could be x or y, whatever is front. Now what I do is I switch the position of those coefficients. How? By placing them on the outside of those parentheses. So what I mean is transform this by taking this 1, bring it down here. Take this 3, put it up here. See how I switch? Kind of like a crisscross? But this 3 is still here, and this is still here. It's not like this went all the way up here. I just duplicate it. So the original 1 is still there. Okay? And the original 3 is still there. Once I did that switcheroo, then what I want to do is distribute the coefficient by just doing the multiplication. So let's distribute by multiplying. That's why I have the parentheses. So 3 times 1y is 3y. 3 times negative 2x is negative 6x. 3 times negative 2 is negative 6. We're going to do the same way to get rid of this set of parentheses. Remember how to get rid of parentheses, distributing? So 3y minus 6x equals 12. We're not there yet with the elimination part. The next thing that we have to do is change all the signs of the second equation. Okay, so that's very important. So take this second equation and just change all the signs. See how it was positive? It's now negative. See how this was negative? It's now positive. See how this was positive? It's now negative. Once we have that switched, then you can combine like terms. So notice 3y and a negative 3y. Boom. You can cancel or eliminate. Why? Because one's a positive and one's a negative. 3 minus 3 is 0. They eliminate. But notice the x's. Negative 6, positive 6, you have to subtract when you combine. And you're going to get 0 x's. On this side, -6 and a -12, since they're both negatives, you add. So here, there's nothing left. All the y's and all the x's disappear. So what we did was that with the transformation, we repeated step 2. Remember, step 2 is where I collected the like terms. Now I have to see, did only one variable disappear, or did all variables disappear? In our case, all variables disappeared. There is no variables. So then look at the leftovers. If you have a false statement, say no solution. If you get a true statement, then this is infinite. So here's my leftover. 0 equals -18. That's definitely false. 0 is not the same thing as a -18. Don't say your final answer is false. Remember, there's only 3 answers you can give me. An ordered pair, put in whatever the ordered pair is, or no solution, or infinite number solution. So you can't say true or false. You have to say, once you realize it's false, you must say your final answer is no solution. Just like how we got it with the graphing to parallel lines, just like how we got it with the substitution method.